Hello to everyone. I am Professor Raja, working as Assistant Professor EC Department, SNS College of Technology, an autonomous institution Coimbatore. In this YouTube video, I am going to discuss about intersymbol interference. So based on my previous YouTube video, if you watch that video means you may have a knowledge about what is meant by I pattern and how the I patterns are occurred in signal transmission. The outcome of these I patterns are used in intersymbol interference, that is, the problem of I pattern can be rectified in ISI concept. Now we will detailedly discuss on the topic. Digital data is represented by electrical pulse. Communication channel is always band limited. When the channel bandwidth is greater than the bandwidth of pulse, spreading of pulse is very less. But when channel bandwidth is close to signal bandwidth, that is, if you want transmit digital data which demands more bandwidth which exceeds channel bandwidth, spreading will occur and cause signal pulses to overlap. This overlapping is called intersymbol interference. ISI causes degradation of signal if left uncontrolled. Similar to interference caused by other sources, ISI can also cause degradation of signals if left uncontrolled. This problem of ISI exists strongly in telephonic channels like coaxial cables and optical fibers. The main objective is to study the effect of ISI when digital data is transmitted through band limited channel and a solution to overcome the degradation of waveform by properly shaping pulse. Raised cosine response meet the Nyquist ISI criterion. Consecutive raised cosine impulses demonstrated that zero ISI property between transmitted symbols at the sampling instance. At time t is equal to 0, the middle pulse is at its maximum and the sum of other pulse is 0. In communications, the Nyquist ISI criterion describes the condition which, when satisfied by a communication channel which including response of transmit and receive filters, result in no ISI interference or intersymbol interference. It provides a method for constructing band limited functions to overcome the effect of intersymbol interferences. The figure shows, if you see this figure, this is the digital data which we can want to transmit in an analog medium or digital medium. So here this square waveform is represented as 1 and there is no data here because the data is 0 and there is a 1 1. Suppose when you transmit here through a channel medium, here it is called the band limiting. So this dotted line shows the band limiting. For example, if the signal transmitting bandwidth is higher than the channel bandwidth, then the symbol will cross the original bandwidth and it will mix it with the next bandwidth. Similarly, if the signal bandwidth is much higher than the channel bandwidth, then it will mix it to other. So if you see the original data, here it is 1011, but if you see instead of 0, there will be some signals are there. If you see this next one, so if you see this next one, here if you see, so because of this mixing, here it will come as 0, but due to the noises, here the signals also considered as a transmitting one. So this will make the signal transmission in a complication identification. So this is the main problem of ISI. The effect of sequence of pulse transmitted through channel is shown in the above figure. The spreading of pulse is greater than the symbol duration. As a result, adjacent pulses interfere. That is, the pulses get completely smeared. Tail of smeared pulses enter into adjacent symbol intervals, making it difficult to decide actual transmitted pulse. Intersymbol interference occurs when a pulse spread out in such a way that it interferes with the adjacent pulses at the sample instance. Assume here this is the polar NRZ line code. The channel output are showed as spreaded with the time period TB becomes 2B, pulses shown. For example, if you see this data 1, it is the upper side, here it is data 0, it is the downer side. So it takes the time period of pulse TB, it takes the time period of pulse TB. 1 means upper side, 0 means downer side. The amount of ISI can be seen on oscilloscope using an I pattern or I diagram. Already I discussed this. So because of this I pattern, we can know 3 important factors. One is how much of distortion is occur, then how much size the eye is opening and how much size the eye is closing. So depend upon the eye closing and eye opening, we identify how much noise is available at the input signal or any data is mismatched, like that we can identify. Then the important criteria is to identify the noise margin. Intersymbol interference. If the rectangular multi-level pulses are filtered improperly as they pass through a communication system, they will spread in time, and the pulse for each symbol may be smeared into adjacent time slot and cause intersymbol interference. If you see the figure, the input waveform is 100. Because of this individual pulse waveform, it will cross and mix with the others. If you see the next figure, 1011, so due to this one is not properly sampled, then they have to mix with the other. So instead of coming to 0, here the signals also appeared. So because of this ISI, we cannot get the output in the proper manner. So in order to eliminating ISI, there are 3 strategies are available. One is use a line code that is absolutely band limited. Second one, use a line code that is 0 during adjacent sampling instant. And the third one, use a filter at the receiver to undo the distortion introduced by the channel. That is, we can use the equalizing process. So we can see detail. For 3 strategies, the first one is a use a line code that is absolutely band limited. It would require synchronized pulse shape and it is not practically used. Then second one, use a line code that is 0 during adjacent sample instance. It is okay for pulses to overlap somewhat as long as there is no overlap at the sample instance, and it can come up with pulse shapes that don't overlap during adjacent sample instance. So for this, we are using raised cosine roll-off pulse shaping model. Then the last method of eliminating ISIR, use a filter at the receiver to undo the distortion introduced by the channel. So basically, we are using equalizer at the receiver. Equalizers are maybe more types, either adaptive equalization filter or a linear equalization filter, or based on the amplitude level or based on the frequency level. There are so many equalizers are used at the receiver to suppress a proper sampling time from sender to receiver. So in this YouTube video, I discussed the use of ISI and how ISI can be occurred in a digital signal transmitting and how this can be eliminated. Thank you for watching my video.